all the companies that I've worked with that are successful have a degree of operator care wherein they participate in these cross-functional teams, operators, maintainers, maybe engineers, to bring an asset, whether it's a pump or a pumping station or whatever it may be, where they work together to identify the defects and they work together to resolve those.
You've said that expecting maintenance to own reliability is like expecting a mechanic to be responsible for a car's reliability. It ultimately comes down to how it's operated. How should organizations shift more responsibility for reliability onto operators? And what does that look like in practice?
Well, let's start with, reliability itself. What is it? Well, as you and I have discussed, reliability is the ability of a production system to deliver the maximum in quality product on time, in full, at the lowest sustainable cost. It's not just the equipment. And of course, operators would have a substantial responsibility for some of the losses associated with that, in changeovers, in shift handovers, and the like. So I think the first thing you need to do is collect data about where your losses are and collect information from the operators about where some of the issues and the problems are that are resulting in those losses, either production related or maintenance related. And then go talk to the operators and find out from them what's frustrating you, what's difficult for you. Now, here's some data, share what you've learned and get them engaged in a conversation about what they might do, given all their other responsibilities, what they might do to help mitigate some of those things. And then you let them help create, the procedures, the processes, the changes that might need to be made. Because if they help create them, then they own them. Now, I've been in some plants that are highly unionized and really, to some extent, maybe too strongly unionized. And so in that situation, what I've suggested is, look, let's look at the issues and the problems, and let's ask ourselves, what is it that operators could do safely, right, and reliably, properly. Now, in doing that, though, we'll say, okay, we're going to put the contract over here for a second. We're going to come back to it to make sure that what we discuss is within the contract. But for the time being, let's just talk about what makes sense, what's appropriate for us to do. And you have a discussion a lot of times with maintenance, maybe even an engineer in the room, because you don't want them doing things that they're not skilled enough to do, or that might be unsafe, that they're not aware of, and that sort of thing. And so you have this discussion about, well, it makes sense. Well, let's presume you spent, half a day or a day, on a particular machine, process, whatever it may be, and you've concluded this makes sense in light of all the other things I've got to do. Well, now you go back, if you're in a union environment, you go back and you say, well, is that permitted by the contract? If it is, you do it. If it's not, you negotiate it. If you're not in a union environment, you just make a decision to go ahead and proceed with it. But the key here is act on data related to, the business objectives and get the operations and maintenance people involved in selecting those tasks appropriate for resolution of those problems. And if you do that, you're much more likely to get, pretty good implementation. Margaret Wheatley said, people own what they create. Well, you have to get them involved in the creative process so they have a sense of control, of purpose, of ownership. And the data, by the way, substantiate this. The more operators are involved in taking care of, looking after the equipment, the lower your costs, the better your performance.
Can you share an example of a plant where shifting reliability responsibility to operators made a significant impact?
Well, I would say not shifting it to operators per se, but shifting it to the production folks, the operating folks, which then promulgates down through the operators. But yeah, in the workshop I do and the presentation I do, I talk about a company called, Eastman Chemicals. Charlie Bailey was the VP of operations there. And he tried to get reliability by focusing on maintenance. And he got some improvement. But it wasn't until he went to the production folks and said, look, I'm going to hold you responsible for reliability, and let's give that some meaning, for production schedule compliance, for maintenance schedule compliance, for maintenance and repair costs. But I'm still going to hold maintenance responsible for those. So he created this environment where they had to work together. In fact, maybe they wanted to work together, and that's when he got the substantial improvement. Now, that same model I've applied in other organizations and gotten essentially the same result. So it's an aligned, cooperative, collaborative environment that you get the best results.
You mentioned that only about 30% of employees are truly engaged at work. What are the key factors that determine whether operators take an active role in reliability, and how can leadership increase engagement in reliability efforts?
Yeah, well, let's back up just a bit. The data comes from a guy named Bob Kelleher, a really sharp guy in organizational issues, and he's done any number of surveys of any number of companies, and it consistently, year over year, it comes out that only about 30% of the workforce is engaged. That is, they truly want to work. They're looking for ways to improve. They're actively engaged. And notionally, around 50% are disengaged. Now, they do the minimum. They do a reasonable job, but they're not going to go out of their way to do much more. And then about 20% are actively disengaged. Now, these are the folks that are very unhappy with work, and they make sure everybody knows it. And so, his view is kind of what I alluded to earlier. You have to address the underlying issues that are creating the dissatisfaction or the lack of engagement. So in my work, what I found you do, for example, I'm in a plant of some sort, and there's a machine that's, always breaking down. And so what do? Well, I pull together a cross-functional team. That cross-functional team sits in a room, with me and maybe an engineer, maybe even a vendor who knows that equipment well. And we discuss what's failing, how often is it failing, why is it failing, what's the consequence of that, and so on. We identify a bunch of issues. Now, the next step, it kind of takes people aback sometimes. The next day, we go out and we clean the machine. And some people say, clean the machine? Why would you do that? Well, the interesting thing is when you clean the machine, you have to get close to it. And when you clean it, kind of like detailing a car, you find defects, problems, issues. Maybe things aren't quite aligned. Maybe they're slipping a little bit. Maybe, things need to be tightened a bit. Just all kinds of defects, little bitty defects. You'll find those and you can correct them. And out of that comes this sense of what? Teamwork. You're all working together, no matter what functional area you're from. You're all identifying problems, and then you're working together to resolve those. And at the end of the day, things work pretty well, and they look better. They're cleaner. They look like they've been cared for and loved. And people take a great deal of pride in doing something like that. So now once you've done that, you pick another one. And when you get done with that, you pick another one. And by the time you get through all of them, you're probably going to go back to the first one and do it again. But it does instill this sense of purpose, pride, ownership, that sort of thing. And it's really, I think it's essential in any organization. If you want to have excellence, you have to get the people involved in delivering that.
What's one simple way a plant can improve operator engagement in reliability tomorrow?
Well, I think I've alluded to those earlier. One simple thing you can do is go talk to the operators about what's wrong? How might they participate? What solution do they see? And get them involved in and support them in doing that. That just maybe an example of this. I had a call one time from a company to come and work on a device called a scarfer. They wanted to do what amounted to an RCM, or failure modes and effects analysis, on the scarfer. It's a big box-shaped, blowtorch that you slide steel through, and they got burners every centimeter or so, and it burns the top millimeter or so of steel off the top of that slab to minimize surface cracking and that sort of thing. So we went and we talked a bit, and I said, well, before we do this engineering analysis, let's go talk to the operator. So I talked to the operator and I said, well, what's the problem with this scarfer breaking down all the time? He said, well, we got a couple of problems. One is the cooling water for cooling the elements of this burner. A lot of times they fail. The cooling element doesn't keep it cool enough. And if we could just change the filter more often, that would resolve that problem. Right? I mean, pretty simple solution. I said, what else? He said, well, when I get steel to run it through the scarfer, sometimes it's crooked. And so it rubs and bangs the scarfer and damages it. Okay, so we'll go up to the rolling mill where they roll the steel to send it to him. And I said, what's the problem? You can't send them straight steel. He says, well, the biggest problem is I get steel from the ovens that's not uniform temperature. Oh, okay. He said, so when I roll it, it tends to curl or crook and damages the scarfer. I said, oh, okay. So I go up to the ovens operator. I said, what's the problem? You can't send them uniform temperature steel to roll. He said, well, my supervisor told me to leave the tops off the ovens to get better throughput. And so cold air goes down the side and cools them off. Okay, then. So, a lot of times these problems have to do with, the sequence of events or the lack of understanding downstream of what you're doing to impact them, a lack of a systems level understanding. And so going and talking to the operators very often gets you a fairly straightforward identification of the problem, and it makes it much easier to, solve the problem. And they become involved in helping you create the solution. So again, it's all about engaging the workforce and helping you identify the issues and being a part of the solution.
In your experience, what are the most impactful reliability-related tasks that operators can take ownership of? Where is the line between operator care and what should remain within the maintenance team's domain?
Well, certainly the things that should remain in the maintenance team's domain is things that operators are not trained or qualified or competent to do, or things that are expose the operator to certain safety hazards or risks. And that's why the maintenance folks need to be a part of that. Now, what they can do has to do with, in each site, looking at the equipment, looking at what the simple tasks are, getting them involved in helping you identify those, and then setting a standard for doing those that's safe, reliable, that they have competency to do. And as I sit here, I can't give you specific examples because it's going to vary. Even within a plant, it's going to vary from machine to machine to machine. So, but again, it has to do with going to the operator and letting them help you identify what makes sense for them to do.
You've talked about operator care being the foundation of reliability. Can you share an example of a company that got this balance right?
All the companies that I've worked with that are successful have a degree of operator care wherein they participate in these cross-functional teams, operators, maintainers, maybe engineers, to bring an asset, whether it's a pump or a pumping station or a saw or an injection mold or whatever it may be, where they work together to identify the defects and they work together to resolve those. And then out of that comes a set of procedures or standards or a checklist that fosters their continued, addressing of those tasks. And it's kind of hard to difficult because it's going to be difficult to identify specific ones because it's going to differ. If you're in a paper mill, that's going to be different from a steel mill, which is going to be different from a chemical plant, which is going to be different from a food plant. It depends on the machine, the process, the issue that's at hand.
Many organizations struggle with operators resisting additional responsibilities in maintenance and reliability. What are the biggest cultural roadblocks you've seen, and how can companies overcome them?
Go to the operator and find out what are the tasks that they could do given all the other things they have to do, such that they don't feel pressure to not do those that are important for them to do, and such that they feel like they're part of identifying, what problems need to be addressed that will make their life easier. Not your life, their life. Because, they're most interested in their life and making it easier, making it more, making it safer, making it more convenient, making it with less hassle. Now, but at some point you have to align that with what's the right thing to do for the business. So there's going to be some give and take in there about what makes sense to do, all things considered. But it all boils down to having these folks participate in helping create the processes and understanding the importance of helping improve the process and of having them having some sort of reward in it. Might be a little money. Sometimes it might be thank you. Sometimes it might be taking folks out for pizza. It doesn't have to be a big, huge thing. You just have to show a little appreciation and consideration for what they're doing and get them involved in hopefully doing it better. Well, let's go back to the, my definition, the ability for a production process to deliver the maximum quality of product on time and full at the lowest sustainable cost. Well, I think in a good organization, there would be some sort of reward for the success of that business, right? Everybody knows that if we do well, we're going to get another 10% on top of our regular pay, okay? And if we do well, I'm going to be in an environment where I have less hassle, less stress, less risk of injury. And so if you can engage the workforce in that and helping them minimize that fear that you're trying to impose something on them that they don't know how to do or feel like they're being oppressed with it, and all you've done is add another task. And the other thing to do is maybe they're doing tasks that don't add any value to the business. So you should ask them about those things that don't add any value, that maybe got established 10, 15 years ago that now no longer apply, that they're still doing. Well, let's stop doing that and maybe do this. But it all has to do with the leadership creating an environment where there's open communication, where there's consistency in the alignment to a particular set of objectives, and where there's a collaborative environment that engages the workforce. Well, it's going to vary from plant to plant, okay? But there are things that come to mind in terms of leading indicators. Now let's back up and let's define leading and lagging indicators. A leading indicator is something you do in a plant that results in improvement in a lagging indicator. So, for example, and I want to give you a maintenance one, then we'll go back to operations. If I do precision alignment and balancing on a rotating machine, that will give me longer life. That will give me lower costs. Well, the leading indicator is, did I do precision work? Precision alignment balancing on every machine. The lagging indicator is I got lower costs and I got higher output. Okay. So the same thing applies to, operators. So, and an operator, if, for example, if I have lots of leaks in my process, well, that creates spills, which creates hazards, which creates work, which, and creates disruption to the process. Well, if you've got 10 spills a month, you can get that down to 1. That's a leading indicator. If you get rid of those spills, then likewise, you're going to have, better, lower cost, better output, and so on. Another one might be alarms. Maybe the system originally set up, and now we're getting, far more alarms than we otherwise should. Well, maybe we ought to go through and analyze all those and begin to change the alarm settings or eliminate the alarms or do something that minimizes the fact that after a while you just disable the alarm until it goes off again, then you disable it, and after a while it has no meaning. So, talk to the operators about that. So things like, spills, alarms, maybe another one might be process excursions. Maybe from time to time you'll have an excursion in the process for one reason or another. And so keep track of those excursions, identify the cause. Maybe it was a procedure, maybe it was an operating condition, maybe it was a piece of equipment, maybe it was instruments going out of calibration. And then get them involved in minimizing, the disruptions of the excursions in the process that go above or below your set points or your upper and lower control limits, and gradually over time, excuse me, minimize the number of excursions. So each one of these is kind of a leading indicator, but if you do that, you're going to have better lagging indicators, lower cost, better output, better quality, that sort of thing. And by the way, it depends on each site what those might be.
Can you give an example of a plant that successfully tied operator performance to reliability without it feeling punitive?
Well, those plants where we've been successful in doing that, then there's some sort of set of, reward, right? Where somebody could be a simple reward, like I said earlier, like buying pizza or taking them out to dinner or, something real simple. In other cases, it could be, well, if we achieve 10% greater production output, there'll be another, whatever, form of, remuneration, reward for you if we do that. And then that provides some incentive. But it can't be such that I still have to do all that other stuff, some of which doesn't add any value and some of which I feel like is silly, unless they understand why it's being done, and then maybe it's not so silly. So you can tie in money, or you can tie in just simple things like, thank you. I really appreciate what you did there.
In discussions about reliability, we often talk about operations rather than just operators. Why is that distinction important, and how does looking at reliability from an operations-wide perspective, rather than focusing solely on individual operators, change the way organizations approach improvement?
The operators are a part of the operational excellence. So one of the reasons you want to think holistically about the operation is this, and it's the causes of all the lost production capacity. So, for example, an operations person would be looking at raw material supply, quantity, and quality. That can impact your operation, right? An operations guy would be looking at sequencing of product changeovers, because that can impact your ability to produce and your overall efficiency. An operations guy would be looking at things like shift no-shows, right, when people don't show up for work, or would be looking at the training and the skills of the operators to do the work and do it effectively. An operations guy would be looking at process changeovers, which can affect your overall production. An operations guy would be looking at things like short stops, where, some of these folks, when they measure this so-called OEE, well, they don't measure anything less than 10 minutes. Well, sometimes what that induces is there's not very many stops that are, over 10 minutes. And so you had a lot of lost production in that, that arbitrary criteria of, it's if it's less than 10 minutes, we don't count it. You need to count everything. So there are other, issues that can result in poorer operational performance that the operator doesn't actually control. And so it's really important that we take that view. But that said, operators are really essential for having a good and reliable operation.
Red Talks features voices driving safety, reliability, and innovation forward in the industrial world. If your work challenges the status quo, we'd like to hear from you. Learn more at redtalk.com/about.